need to handle 1 billion gigabytes daily. And, Bitcoin, Ethereum are not there. They're nowhere near that, right?
Obviously, the first option is you can update or modify the protocol of the blockchain itself. This other option, sidechains, is another way of approaching the scalability problem. And how do we take some of the data or processing off the main blockchain, off the layer one, to reduce the burden on the network itself?
They're effectively separate blockchains and they're linked to the main chain. And the point there is that they can have their own security, their own consensus mechanisms potentially, and can differentiate quite significantly from the main chain. Welcome to another episode of the Untangling Web3 podcast. So it's 2024, crypto is booming, and there are thousands of crypto tokens and blockchains right now out there. Some of the most popular you're all aware of, or I hope you're all aware of by now: Bitcoin, Ethereum, Cardano, all of these ones. Adoption is coming, and that's quite exciting, but as people are coming to this space, they're often seeing that performance is limited, especially with some of the more major chains. And as a result of this, there's been a boon in the areas of actually building on top of these chains to get more scalability and more functionality. So we did an episode on layer twos, which is one way of solving some of these scalability issues. But today we'll be talking about side chains and what side chains are, why they're needed, and how some of the major ones work. And as ever, I'm joined by my glamorous assistant and co-host Jack Davis. Are you excited for this one?
Very excited. I've been demoted to assistant though, so I'm not so excited about that. But yeah, I'll take what I can get at this point. But yeah, no, this is a very relevant episode, and as you said, we covered the layers of blockchain recently, and the whole motivation for those being how do we improve scalability, solve this scalability trilemma, and yeah, side chains are another piece of that puzzle, not just related to the scalability side, but I think it's something that definitely warrants a whole discussion on its own. So that's why we're here today.
Yeah, there's this episode, Layer 2s, and would recommend going into that one because that goes into the background in more detail. But effectively, with blockchains, we have three characteristics that we're quite focused on: scalability, which is transactions going through the door; security; and decentralization. And Vitalik Buterin, the man, the myth, the legend himself, described or had this idea of a scalability trilemma problem where you could only have 2 out of 3 of these characteristics being implemented properly. And that's a bit of a barrier, isn't that right, Jack?
Yeah, it's a significant barrier. Again, which of those three elements are most important to you will depend on which camp and blockchain you're in or what your actual use case is potentially as well. But the generally accepted notion, as you said, is you can't have them all at the same time, which means you have to think about what the trade offs are, whether you sacrifice scalability for decentralization, scalability for security, or another combination of the three. That ends up being the question you have to think about when you're implementing a new blockchain or trying to facilitate a new kind of Web3 use case normally.
And we often describe blockchain as the piping for the internet, right? And I think some of the stats around the internet and what's exchanged today are you would need to handle 1 billion gigabytes daily. And, Bitcoin, Ethereum are not there. They're nowhere near that, right? And if we think of them as digital cash solutions, like they were meant to be in the original implementations, they're needing to do billions of transactions every day. And they just don't hit those thresholds right now. So these are some of the trade-offs. Like if the network increases its scalability, it can often lead to centralization. If we try and increase the transaction speed and throughput, that can sometimes lead to reduced security. Maintaining a high level of security and decentralization often leads to lower scalability, as we're seeing right now in the current implementations of Bitcoin and Ethereum.
Yeah, exactly. So this is the big question on everyone's lips. Often people will say, "What's the purpose of Bitcoin if you can do 7 transactions per second?" Even Ethereum, with lots of the recent developments and the shift to proof of stake, can still only do around 30 transactions per second on average. So in the previous episode on layer twos, we said, what can we do to resolve this scalability issue without sacrificing all the aspect of decentralization or security that we mentioned? So in the layer 2 episode, we talked about, obviously, the first option is you can update or modify the protocol of the blockchain itself. So make changes to layer 1. And we said there are some difficulties associated with that. You want to have a stable protocol that doesn't change all the time. The second option then is to do things on top or to the side. So we talked a lot about the on top option, which is kind of the layer 2s. And there's some debate about whether side chains are an example of layer 2s. I think there is a distinction between them. But this other option, side chains, is another way of approaching the scalability problem. And as I said, it's not all about necessarily just for scalability, but it's one of the primary use cases is how do we take some of the data or processing off the main blockchain, off the layer one, to reduce the burden on the network itself and approach scalability through that different mechanism, essentially.
Yeah, you're right there. I think when I was going through some of the materials in preparation for this one, I found it hard in some cases to differentiate between the two. I think that layer twos is a bit more general, but there are definitely certain types of layer twos that seem, in my mind anyway, to fit more in the kind of the side chain definition. But at quite a high level, layer two solutions operate on top of the main blockchain. They bundle transactions typically and then reference those transactions back on chain, increasing the scalability and reducing the fees. And typically they're almost completely reliant on the security of the main chain there, the layer one there. Whereas side chains, on the other hand, they're effectively separate blockchains and they're linked to the main chain. And the point there is that they can have their own security, their own consensus mechanisms potentially, and can differentiate quite significantly from the main chain. But they have this linking mechanism, this two-way peg that we'll go into a bit more detail on, that enables assets to be moved between the two chains. And this can lead to increased functionality and scalability on the side chain compared with the main chain.
Yeah, so the kind of the definition, as I've seen as well, and that you articulated, is your side chains are completely separate blockchains, and they don't necessarily need to have all the features of a normal blockchain. It doesn't need to have this completely decentralized network if you want to have a kind of application specific side chain, for example. But it's a separate blockchain, and as you say, linked to the main chain. So the differentiation between a side chain and a layer two, in my mind, and most people seem to say, is that a layer two solution inherits the security of the underlying blockchain that you're using, the L1 that you're building the L2 on, whereas side chains, they don't inherit that security model and they introduce their own security model purely for the use in that sidechain environment, essentially.
Yeah, that makes sense. And I guess this idea was kind of first originated in 2014 by quite a famous man in the space, Adam Back. He's the inventor of Hashcash, right? But he highlighted there was a lot of the potential issues, right? He saw in the early days around scalability, privacy, and trade-offs in Bitcoin that would need to happen because of these issues. And he theorized with a few other people about side chains and the function they could play in the space for facilitating digital assets, tokens, with all these kind of wild and wonderful things that we just spoke about.
Yeah, exactly. Adam Back invented Hashcash, and that kind of looks like a precursor system to the proof of work we had in Bitcoin, right? So someone who's been involved in the ideas that eventually became Bitcoin, really, and in that working in that space, in that cryptography realm, and of distributed ledgers for quite a long time. And yeah, as you said, he brought forward this concept of how do we build side chains linked to the main chain.
Okay, then. So, like we said, a side chain is essentially a separate blockchain that is attached to the main chain or the parent chain, I think they typically refer to it as. And this allows you to move assets back and forth between the two chains. So it functions completely independently with its own protocols, rules, governance, but remains connected to the main chain. And that's probably the important bit here is there's this connection, this two-way peg mechanism, which allows assets to be securely transferred between the side chain and the main chain.
Yeah, and I think two-way peg is typically how sidechains are done now. I've actually seen examples with a single-way peg for kind of again more application-specific, less generic sidechains where you just want to lock up an asset and then start using something else on another side chain, maybe model state transitions in more like a supply chain thing. But if you're actually talking about wanting to lock up and use digital assets on another blockchain, then that always tends to use this two-way peg mechanism. That's why we want to focus on that now. So what does the two-way peg really mean? Well, it means you have two separate blockchains. You have a native asset on each of those blockchains, so like Bitcoin and Ethereum. And essentially what you want to do is you want to take assets from one, you want to pause the use or lock them effectively on one chain so that you can unlock and start using the assets on another chain. That's the kind of a core aspect of side chain two-way pegging, basically.
And this, to me, like for those people that listen to our layer two episode, sounds like side channels, right? The whole point of a side channel is you commit some funds to a side channel, and then you can do like lots of transactions based on that, right? So yeah, and then I guess on the other way, the point is here is it's two-way peg. We can now transfer assets back from our side chain back to the main chain because they're locked and unlocked, which is controlled by this two-way peg.
Yeah, I like that you drawing the comparison between the layer two solutions like your Lightning Network, for example, which is where you are locking up assets on one chain. The difference is you're still using the assets of the same chain in the Lightning Network. You're not transferring to using new assets on a new blockchain like Ethereum. So, yeah, you are locking up on one, starting on another. And there is an element of cross chain communication here, which is kind of where the difficulty comes in. And we'll talk about that later. But the blockchains, they're not sentient beings. So you have to have some mechanism of communicating state from one chain, the origin chain like Bitcoin, to the destination chain like Ethereum. And that's where you might have some third parties come in and act as a kind of relay between them.
Yeah, I mean, just to make this a bit more digestible, should we go like through a run through of how this would work? So, in this hypothetical situation, Jack wants to use Bitcoin. He's obviously got this addiction to crypto kitties, but the Bitcoin network is too slow and too costly for him, so he can't get his kitties quickly enough. So he opts to use this new side chain called Speedy Chain for faster and cheaper transactions. So Jack locks 5 of his Bitcoin. He's doing very well thanks to this podcast, of the main Bitcoin network into a special address controlled by Speedy Chain's pegging mechanism. Once these are locked, he receives 5,000 Speedy Bitcoins on the Speedy Chain. Jack can now use his 5,000 Speedy Bitcoins on the Speedy Chain to make whatever transactions he wants far faster and cheaper than the Bitcoin main chain. So he buys some kitties, he sells some kitties, and then when he's done at the end of the month, maybe he starts the redemption process on Speedy Chain, requesting to convert his now 4,000 Speedy Bitcoins back into normal Bitcoins. So he gets his 4 normal Bitcoins back. They're sent to Jack's main Bitcoin wallet. And throughout this process, the security and the integrity of the assets, the consensus mechanism that controls them both actually ensure that security and integrity. Okay. And he's done all that faster and cheaper, and he's got his kitties. So, make sense?
Yeah, I think so. And that's the key point at the end there, I think, is where the security lies throughout the process will just depend on what form of sidechain you're using, right? Either it's one of these inheriting ones, so the sidechain inherits the security of the parent blockchain, or it's using its own consensus mechanism. So in either case, the security properties might differ, but overall, that's exactly how it's working. And I think that's a really nice description. So one of the key aspects of how it works, I think you described there, is how do you actually transfer these assets across chain between the main and the side chain? It's crucially this locking and unlocking process, right? So when you transfer it to a side chain, you need to be locking your assets on the origin, the parent chain, in some kind of special address or some kind of contract. And we'll go into the different options for that in a little bit. But that's the core. You lock it in one place, and then you can start going and using it in another.
Yeah, I mean, we can go into some of the different types. There's a whole range of different ways of doing this, and they can get quite fantastic and complex at the same time. So maybe we'll just go through some of the main ways at a high level. So the 2 high level areas. One is around federated pegs, and the other one is around cryptographic pegs. The federated probably is the more, I guess, this is simpler of the two. You effectively have some trusted entities, I guess, in a way. We could think of these as miners, maybe, who manage the actual pegging and controlling of assets and releasing of assets. And you effectively need a consensus among these selected nodes for the transactions. So you have these parties who effectively say Jack is allowed to have these 5,000 Speedy Bitcoins for those 5 main Bitcoins that he actually transacted. That's good because it's quite simple and easy to understand that you have these people that are managing it. But one of the biggest fear factors around this style is the idea of a centralization risk, right? If we have 2 or 3 parties that are managing those transactions, there could be a single point of failure if one of them's a bad actor, or if a few of the nodes go down for whatever reason.
Yeah, exactly. So the federated peg, obviously the first type of the two-way peg that you can have. And as you say, you are essentially putting full trust in the consortia of entities that are managing this peg, right? So you're basically saying, how do we make these 2 blockchains communicate, the parent and the side chain? We're just going to delegate that whole problem to the set of trusted validators or nodes or whatever you want to call them. And this is why it tends to be the more popular choice for private blockchain environments, right? Consortia blockchains like your Hyperledgers, that kind of model. The second option, which is kind of more, let's say, Web3 native, is what you call a cryptographic two-way peg. So in this case, as the name suggests, you're using cryptography, you're using the mathematical proofs to validate whether the funds have been locked on one chain in order to release them on the other, and vice versa when you go backwards. So In the simplest case, this can be done quite easily with a swap between Bitcoin and a sidechain of Bitcoin, for example. You can lock funds on the main Bitcoin chain and then just get a simple SPV proof, we call it, or a Merkle proof that the locking transaction does exist in the Bitcoin blockchain, and then you can release the funds on the sidechain. So that's the simplest example. You can also mediate that with a smart contract if you're in an Ethereum environment. So you just send things to this locking smart contract, and the proof that it's in the Ethereum blockchain and part of this contract is then enough to go and unlock funds on the side chain. So obviously this option is, as I say, much more akin to what we come to understand with Web3. It promotes this idea of decentralization and security, more inherited from the underlying or parent blockchain itself. The downside being that it can be a little bit more complex and more computationally intensive to do these things, and because you're not trusting another entity, you take more of that responsibility to verify things back onto you as a user or an application.
Yeah, and I guess when we were talking about layer twos, this is one of the technology we talked about. It's like zero knowledge proofs and how they're gaining a lot of popularity because, 10, 15 years ago, everyone thought they were too complex to actually be deployed in a computationally efficient way and actual something that is scalable and easy to use. But I guess more and more we're seeing this technology come to light. And like you say, you're removing the single points of failure or the human intervention by just relying on this, let's just say, black box maths right now that can do all this stuff. So yeah, they're the two high levels of actually kind of two-way pegging these things or agreeing and kind of managing the assets in a two-way peg. Within that, there's a few different flavors as well about how assets on the one chain relate to the other. So we have one called lock and mint. The other one is called burn and mint. And then the final one is atomic swaps. And I think we'll definitely go into more detail on atomic swaps because this is a huge area of interest for, Web3 in general. But let's go into a bit of a deep dive of each of these and how they kind of differ from one another.
Yeah, exactly. So if you want to go and implement either of those two high level types of two-way peg that we mentioned, you go and then choose one of these kind of technical options for implementing. So the first one, lock and mint, it kind of does what it says on the tin. As we've been describing, you are simply locking the funds on the main chain, the parent chain, and then minting new funds on the side chain. Okay. So it's different to having two main chains interacting, because if you were going from BTC to Ethereum, that's not really a side chain operation. Ethereum already has native assets, but on the side chain, you might well want to mint the new asset. So that's kind of how it's working. And you're using the tokens locked on the parent chain effectively as the collateral to maintain the kind of consistent value across both of those chains, right? And there's some advantages to doing this. So obviously, because we've locked the funds, they will remain locked and serve as collateral through the lifetime of the sidechain assets. So you have that value consistency. It also makes sure it's portable and you can then have the utility across both blockchain ecosystems, right? So it's kind of a natural way of doing things. The downsides, as we said, it relies on the kind of security of whatever locking or minting mechanism you're using. And if you're putting trust in one of these consortia to do this and do the communication between the parent chain and the side chain, then you do encounter potential vulnerabilities and also that complexity that can come in if you're going down the more cryptographic proof route.
Yeah, that makes sense. And the second style of this is burn and mint. It's kind of quite similar overall, but the original tokens on Chain A that are kind of locked up in the first scenario we just talked about are actually permanently destroyed or burned, is probably the term that we use in this kind of area. And we effectively create equivalent tokens that are minted on Chain B. And I guess the main point of this is to ensure there's no increase in total token supply across all of the chains. One of the advantages of this style compared with the previous style is it completely prevents double spending by effectively permanently revoking from chain A when minting on chain B. And this ensures kind of consistency. If I put 5 Bitcoins from chain A to chain B, destroy those 5 Bitcoins, then have 5,000 in chain B. If there's an equivalence there, then I can say there's no increase in overall supply because of that equivalence. And I guess one of the things that this does as an advantage, it simplifies the kind of the cross blockchain. We start to talk about interoperability between blockchains. It simplifies that process by not having to manage hundreds of different tokens for any one peg or multiple pegs at the same time. The disadvantages are kind of obvious as well. Like once they've been burned, they've been burned. So things can go wrong quite easily potentially, and potential for losses if the bridging or minting process is compromised. And this has actually happened in a few different cases. One of the examples is around this chain port where some were burned mistakenly and they weren't able to get those back.
Yeah, it's one of those risks, and that's why you want maybe a bit of a time delay between when you burn them on the first chain and remint new tokens on the second chain. And I just want to maybe take us on a tiny little aside here, because I think this is the first time we've discussed burning as an idea in Web3 so far. And actually, it's something that is widely used outside the context of sidechains too. So in Ethereum, by contrast with Bitcoin, which has this kind of fixed supply that we all know and is well defined, in Ethereum, tokens are constantly being minted. Ethereum is constantly being minted or mined by blocks being generated, but it's also being burned through transaction fees. So transaction fees at Ethereum, as of the last few years, now get burned. So this is a concept that is quite well tested in that area. So I just wanted to mention that because we've never talked about it before. The third option, then, if you don't want the lock and mint or burn and mint, is a really interesting technique. And has actually been around for like 10 years at least. I think it's one of the really early innovations that happened on top of Bitcoin, actually. So, atomic swaps are this trustless exchange method that you can use. So, you can directly swap tokens between the two chains. And it also has less reliance on a third party. So, basically, how this works, it's all about this word atomic. So atomic means, and this is term in computer science, but it basically means either two things definitely happen or neither happen. So the two events are either funds are transferred from one chain and minted on another, or vice versa. So those are the two events you're talking about. And atomic swaps achieve this. There's a few different ways, but the basic way is by setting up or pre-preparing a smart contract or a pair of transactions in Bitcoin and exchanging a piece of secret information that's kind of tied to those transactions. And as soon as either party, so this is typically for counterparty cases, right, where you might have someone on the main chain who has assets and someone on the side chain that wants assets, they're going to swap between them. By revealing this piece of secret data, both of them then effectively receive the assets on their respective chains. So it's kind of a little bit magic, but it's as simpler than something like zero knowledge proofs.
I guess one of the points around this is like kind of key to the entire Web3 blockchain crypto space, right? I guess previously these kind of exchanges of different assets would always be overseen by a third party or an intermediary. And what you're saying is we can now reduce that reliance on a third party and push more of it to technology, to these smart contracts to say, okay, if I give you X and you receive X, then you will automatically be given access to Y. And, you know, that creates efficiency gains and why it's such a boom in kind of industry in Web3.
Yeah, exactly. And it's very peer to peer in nature. You don't necessarily need third party infrastructure to mediate an atomic swap, which is why I think they're so powerful. On that point, now we've covered the three main mechanisms for implementing a two-way peg. I just want to touch on the definition of what we call a bridge. So this is kind of related to sidechains, but again, probably for another episode, but just because it is relevant. So a blockchain bridge is referring to the mechanism for communicating between two different blockchains. So you can use a bridge to communicate between a main chain and a side chain. You can also use them to communicate between two different main chains like Bitcoin and Ethereum. So you'll often see the term bridges popping up when you're talking about side chains, because that is sometimes how you might implement a federated two-way peg, for example. So just a comment on that. And typically, a lot of the time, we do have third parties involved with the bridging mechanism.
Yeah, I think the terms here, they have trust-based bridges, which is like these centralized, where you rely on a central authority to manage the transfers, you know, which are usually typically more simple, and maybe there's an efficiency there because they are centralized in terms of cost. And then you have the trustless, which are the decentralized bridges, where they operate without this central authority and they use smart contracts and decentralized asset transfers. And this is kind of the space that's maybe a bit more interesting, but a bit less known and a bit well, it's these black boxes, right, that we're constantly talking about. And we have issues with both, right, at the end of the day.
Yeah, exactly. And I think it's important to be aware of whether or not your sidechain mechanism is using one of these bridges and whether it's a centralized bridge or not. I think it's something to consider because, as we'll see in a minute, there are like a few different issues you have with the hacks. But for now, let's stick with the positives. So, what are the main advantages and pros overall of sidechains? Well, obviously, as we said at the start, they're designed to address this scalability challenge. So that's something they do quite well, is that they can significantly increase scalability of a blockchain network by adding side chains. I've seen them posited as an early scaling solution for Ethereum, having many different side chains associated with the main Ethereum blockchain. So again, the idea here is that you can basically go from one transaction on BTC that represents state changes from 1,000 transactions on Speedy Chain in the example you gave earlier. So that's basically a way of alleviating all that congestion, improving throughput via taking things through the side chain.
Yeah, that makes sense. That's probably one of the most obvious kind of benefits of this, and probably the point of most of them, right? The next one is around customization and innovation. Like we said before, it's actually really tricky to edit these layer ones. They can lead to forks, or you don't want your underlying protocol that you've based your app on to change every week or something like this, right? That is not a reliable protocol, and that's not how TCP/IP works. It's not how blockchains should work. So it allows developers and innovators to actually change consensus mechanisms, features, governance structures, play around with them in this kind of less stable setting, knowing that things could go wrong, and they can test ideas and maybe see if they work and eventually deploy them back onto main chain potentially without fear of everything going wrong on the main chain. So that's another big benefit of using side chains over main chains.
Yeah, exactly. They can operate like a test net essentially for a given
Mm.
application. And as we said earlier, it's not always a scalability solution. They're often application specific. So you might do something that doesn't even involve tokens really on the side chain, and it's more for recording state changes in some other process, right? But you still have that two-way pegging aspect. Another one of the big advantages, obviously, as you can kind of guess, is interoperability. So it's kind of the definition of a side chain in how you bridge between them and how you connect a side chain to a main chain. They have to be interoperable by definition, so you can get between them. So it's a good example of interoperability between blockchains working in practice. And really, I think, as I mentioned with the bridges, that whole concept has now extended to complete cross ecosystem communication since starting with the sidechain idea in back in 2014.
Yeah. And I think on the kind of the previous one around innovation and customization, adding extra features to layer ones, we see a lot of the technology like the zero knowledge proof stuff actually being used obviously to enhance the privacy of the users on these side chains. So this is another big thing is they tend to, well, some of them anyway, pitch themselves as a more private and confidential version of the main chain. So what's one of the best examples? Lightning Network. That's one of their primary goals as well, apart from scalability and reducing costs. They also say they actually preserve more privacy by using those chains over the main Bitcoin chain. So privacy and confidentiality is another big pro for this area.
Yeah, 100% agree. So, onto the kind of cons and the flip side of all that. As we alluded to, one of the biggest ones is the security risks associated with the side chains themselves, especially if they're not inheriting the main parent chain security model. Then you have all sorts of other complexities and vulnerabilities that you might get into. And we've seen this through so many hacks of bridges in the past, right? So, in 2022, I remember this report that came out from Chainalysis. They said that 69% of all funds stolen in 2022 were from bridge hacks. Okay, so it was the
Whoa.
top exploit in Web3, and I think the biggest one. I remember this at the time. It was really shocking. It's called the Ronin bridge, which was used for Axie Infinity, right? Which is very similar to it's kind of modern day version of Crypto Kitties to bring it back to that. But in that hack, there was around 650 million lost, right, just from this bridge hack, and they did that by compromising a validator in this bridging system. So again, as soon as you put some trust in these new entities, that's where all the risks can come in.
Oh my god! And yeah, that's scary, isn't it? We've talked about this a lot in the layer two episode, where we're saying that you have derive all this security from the layer one. As soon as you kind of extrapolate, there's going to be a vulnerability there, whether it's in layer two itself or the thing that connects you to the layer two, and that's always going to be the weak point, right? You're only as strong as your weakest link. And on that point there around the compromising of the single validator, there's also another concern here is around the centralization risk. We talk about these kind of federated consortiums that are managing the pegs. Maybe it could be 2 or 3 individuals, and you'd assume maybe they're less distributed or less decentralized, if we want to use that term, than the layer one. So there's obviously a concern there, a centralization concern, that it's quite easy to maybe compromise one of these because they have less security, or because you're relying on this single point of failure potentially, then issues can arise like the one you just mentioned. So that's another big concern, is the risk of centralization and single points of failure.
Yeah, especially if that's going to be important to whatever you're doing on that side chain, then you have to really take that into consideration. Another key aspect to consider is, as I said, there's additional complexity around the security model, but also just the usability of sidechains themselves. So as soon as you're adding more layers and more things to do, effectively this bridging process, the new consensus mechanism in the sidechain, then all of that kind of coordination required becomes very complex to do. So there's more to manage. You have all these kind of communication channels off chain that are a whole new headache to fix, especially for developers and things. So that's an issue. And then on top of that, you get this risk of fragmentation. Okay, if you have many different side chains which all choose a different consensus mechanism, different formatting, for example, then the interoperability you get between the main chain and the side chain may be lost by not being interoperable with other side chains, right? So
Mm.
you gain it in one area, but you might lose it in another.
Yeah, it's an interesting one. That I did think of that previously. You said it's a pro for interoperability to have these side chains. They can kind of act between everything. But obviously, the best thing for interoperability would probably be everyone using one system. Everyone either on Ethereum, everyone either on Bitcoin. And these side chains sometimes can change so much that, like you say, it actually makes it harder to be interoperable with other chains, for example, and actually creates more divisions and they effectively act like forks. Like some side chains are so popular that you can imagine them eventually becoming main chains. Like Polygon's an example, right? They kind of sold themselves initially as this side chain to just build on Ethereum, but now they're offering like layer one solutions. They're offering these kind of aggregator solutions because they've become so popular. So in a way, that kind of divides the community even more so.
I'm glad you kind of now we're getting into concrete examples of them. That is a really good point, actually, you've made there, that the purpose of sidechains can very much change over time. So, if you leave your assets in there for a very long time and don't go back to the main chain, then things might change under you. Another interesting one, I think, is Rootstock or RSK, if you've ever heard of that one. It's probably one of the first sidechains I ever heard of actually in production. It's particularly interesting. So I think it's from around 2018 and it was designed for Bitcoin, and it kind of used this idea of merge mining, right? Which is where you're doing mining for the side chain, but you're kind of reusing the proof of work from Bitcoin. So effectively, you could think of it like doing proof of work mining in the side chain, but just doing that through the existing proof of work mining in Bitcoin. And how this works is you'll basically have a lower threshold for mining a block in the Rootstock sidechain than the Bitcoin blockchain, right? Because otherwise you probably just mine the Bitcoin blockchain if you had that much hash power. But it's a very interesting and innovative way of thinking about things, I think.
Yeah, so what their main goal was to bring smart contracts to Bitcoin, right? We've kind of talked a tiny bit and mentioned in the past that there is some smart contract and smart language kind of functionality in Bitcoin, but it's misunderstood and often misused, maybe. And the goal of this Rootstock was to primarily bring smart contract functionality and decentralize that to Bitcoin, right?
And I think that's really interesting, right? Because people often say, well, Bitcoin's not Turing complete language. How do you do interesting things on it? And actually, just using a sidechain specifically to act and behave like a smart contract is one of the really useful things you can do and has really been popularized in the last few years as a way of doing smart contracts on Bitcoin.
Yeah, and I saw one of the interesting things about this project you kind of mentioned there with the merge mining. What they were using, they were kind of relying on Bitcoin's immense hashing power that was going on for security, but there was also this reliance on this kind of, I think it was a multi-sig setup, wasn't it, for actually kind of doing the two-way peg between that. Like we said, talked previously about consortium and individuals and entities actually managing how assets are transferred between the chains, and there was a kind of a big fear that there was a big reliance on these trusted entities in the middle that could potentially act maliciously and would be compromised. I don't actually know if that's occurred to date, but there was a lot of fear from, say, the Bitcoin maxi environment saying this could happen and might happen, so we shouldn't be reliant on this kind of this mechanism for exchanging between the two chains.
Yeah, again, myriad concerns come in when you start talking about side chains in various contexts. But I think the main takeaway for me is that they kind of extend the functionality you do have natively with Bitcoin. So of course, you're going to add some more concerns, some more security vulnerabilities potentially. But if you can get over those, then the functionality you get out is interesting.
So let's talk about Polygon. This is probably one of the most popular kind of side chain layer twos, whatever it is. I think we just find it as a side chain right now, but like we said, there's a lot of offerings coming from Polygon. They initially started as this scaling solution for Ethereum, right? The idea of like increasing the number of transactions, the transaction costs, but they've kind of evolved significantly. They offer the side chain, standalone chains, plasma chains, like aggregator chains. They're offering everything right now, and it's no surprise. Like they've become extremely popular. Whenever you see like in terms of chains and most popular use cases for like gaming, DeFi, all these kind of things, like Polygon is always at the top or near the top. There's so many projects that are building on there right now. They've got this footfall and they're like, okay, we can do almost anything now. Why don't we just build our own chain potentially?
Yeah, and we saw this with our conversation with Colin Butler from Polygon Labs. And he had a really nice description of Polygon now, which is quite different, I think, to what it was a number of years ago when it was Matic. And that it's this way of aggregating liquidity with minimal trust provisions, basically, which is very different and a much bigger goal for the whole system than just a side chain and layer two, effectively, for Ethereum. But yeah, it's had its own issues as well, as I'm aware. So there's been a few network outages, which again you'd expect in a side chain or layer two system. It's normally the parent chain, the L1, that you want to be, have 100% uptime like Bitcoin. You never want it to go down. It's had its own issues like that, but how much of that is an issue? How much of that does that affect users? Typically, people have a very fairly good experience with it from what I've seen. The other issues you have are around the kind of multi-signature usage. So you referenced that before. It seems to be one of these features of sidechains, right, or these other systems built on top of a base blockchain. The fact that you have a few delegated entities who are involved with all the funds in these side chains is can be a bit of a concern, especially for, as you said, like the crypto maxis who don't like that kind of centralization risk.
Yeah, and I think that when we had Colin on, he was talking about their Polygon's $1 billion investment into zero knowledge tech, right? So I think they've seen that this is a problem right now. Maybe the community is not completely okay with having this federated model, and they're pushing more and more to this technology model, having zero knowledge proofs that actually dictate all of this because it's more scalable. So it'd be really exciting to see. And I think they're already starting to implement some of it now, but I don't know if that's the main way in which they peg to Ethereum right now or not. But like we say, because Polygon's such a major chain right now, it's kind of it has a lot of advantage, obviously being a major side chain, but it has some of the pitfalls as well of being a layer one main chain, in that you can't all of a sudden change to a different consensus or change the two-way peg, because the entire community might be outraged if something goes wrong, like we've just seen in some of the examples. So it's got the good bits and the bad bits, maybe.
Yeah, exactly. And I think a final example or two that we should think about as well is these kind of multi-chain architectures that have been coming out over the last few years. So things like Avalanche, also Polkadot, have these multi-chain architectures where you have like primary blockchains or P chains in Avalanche, for example, and then these subnets or X chains, right? These are effectively your side chains. In Polkadot, I think they call them parachains, right? So they're kind of pseudo chains. They exist around the main system. Again, at this point, it gets so abstract that I struggle to completely understand what we're talking about. But I think it's worth just mentioning that these are all similarly around the scalability issue, right? They're trying to enable rapid transaction finality in particular, because that's one of the issues people have with Bitcoin. Finalization of settlement on Bitcoin takes 10 to 60 minutes sometimes, depending on the transaction fee you're sending. But these kind of platforms have gained so much more attention now for the throughput they're able to offer, the low latency, and a lot of that is from this kind of novel multi-chain architecture. Again, I don't really know what the security implications of these multi-chains are. I don't want to comment on that, but it's just worth being aware of, I think.
Yeah, when I was reading, I think most people who are kind of invest in the space know about Avalanche, right? It's quite a popular kind of chain. But when I was reading into it, I was like, oh my God, this is so incredibly complex. Like, maybe we'll get to a stage of the podcast where we can spend a whole episode talking about one chain in particular, because you can't just brush over Avalanche and cover even a percentage of it, right? It's really complex what they're doing. But I think it's an interesting point that they're really targeted towards interoperability as well. Because like we said before, you kind of have this sunken cost fallacy where people are investing so heavily into certain chains and then finding out 5 years down the line, and tens if not hundreds of millions of pounds of investment, that they don't actually have a lot of the features or the scalability or the throughput that they need for their functionality. It's like, hey, they're not going to start from fresh. It would look pretty ridiculous for them. So they're looking more and more at the interoperability and how they can actually use what they've built already, but still leverage other chains and have this cross-platform functionality. So yeah, a lot of kind of attention on chains and systems like Avalanche and Polkadot right now.
Yeah, so I think that probably covers this topic of sidechains. I think we've probably spoken for far too long about this topic, but just to summarize again, what are sidechains? They are systems or additional blockchains you can add to a parent or main blockchain to increase scalability, efficiency, reduce costs, or just implement a completely different system on the side. You have a couple of different options for how you implement them. So they can inherit the security of the main chain, or they can have a completely different consensus mechanism. Usually, the way you get in and out of the chain is what we call these two-way pegs. And again, there's a bunch of different ways of doing those. But yeah, the take-home message is that these are the appendages of the blockchain, right? So they're not necessarily layer twos; they're add-ons that help you to do something or improve the scalability.
And similar to what we said about layer twos, I think that the future is probably bright for side chains, purely because what we're saying is that their main purpose is to increase transaction throughput and reduce cost and decrease the time for finality. So those things are really easy to sell, and there's very defined metrics for them. They're really easy to communicate, to say, my chain has X 100,000 per second transactions. It costs this much to use, and it takes a millisecond to process a transaction. But when you're talking about the things they actually lose because of that, which is the security and sometimes decentralization, That's a much harder sell. It's really hard to sell how secure a network is. It's really hard to sell how decentralized the network is. So I think more and more, especially as we have this kind of institutional adoption and people who aren't necessarily Web3 and blockchain native come into the space, what they'll be sold on will be the cost, the throughput, and the latency. It's a much harder for networks and chains to sell the security and the decentralization. So I imagine there'll be a big boon in sidechains and layer twos because of that.
Yeah, that's exactly the point I wanted to end on, right? We've spoken a lot about institutional adoption recently, and I think sidechains are probably one of the most tempting ways for big institutions to get involved in blockchain. You know, they've done the private blockchain stuff now, the pure private blockchain, and they kind of have abandoned that more or less. And now dipping their toes into public blockchain and getting the benefits, the mutability of that main chain, the security for whatever it is. There are so many use cases for institutions that where they can sacrifice trust, right? Because they might be operating in a consortium environment. So a side chain makes perfect sense for them to do that as a way of experimenting or even building products, as we're now seeing. Colin Polygon is doing this for loads of institutions, right? So yeah, I think that's where I see side chains being super useful in the very short to near term before we kind of really solve the interoperability problem. So yeah, I think that rounds things off nicely. So thank you for listening wherever you may be, and join us next time to untangle a little more of Web3.
Thanks for tuning in to another episode of Untangling Web3, produced by Emma Camilleri.
Don't forget to send us your thoughts, questions, and comments on social media, and be sure to follow us on your favorite podcast provider to catch the next episode. See you next time to untangle a little bit more of Web3.
The views we express here are our own and do not reflect the views of our employers.